Great. Well, testing in prod. Hey, everybody. So I'm Markus from PropellerHeads, and I mostly do all the product planning and research there. And if you don't know PropellerHeads, we've spent the last 2 years in this little corner of DeFi that is very often abstracted away in the solvers are going to take care of it. So this is exactly what we did. We've been building solvers over the last 18 months for CowSwap, for UniswapX, for 1inch Fusion, and for many others who were using our APIs. And we've spent much of our time wedged between two very prominent parts of the DeFi trade supply chain, which is the liquidity, all the DEXs, but not just the DEXs, also the lending protocols, the stablecoin protocols, the restaking protocols. And on the demand side, all of the solver auctions, the wallets, the traders, HFT traders, anybody who wanted to trade and execute a trade. Now, both of these are very, very well known, but solvers, I think, often abstracted behind a box. Solvers, searchers, they're going to take care of it. I'm going to break open this box a little bit today, because I think it's important that we look into how this DeFi trade supply chain is being built, and why maybe, if we're not careful, this DeFi trade supply chain will centralize and then have rippling effects on everything that we build in DeFi. And to give you some empathy for what it is like to be a solver, one of the most important parts for solving, and also the hardest parts, is to integrate all of the different liquidity sources. Now, it might seem so simple, right? There's all these public interfaces, and I can easily check their code and then integrate them into my solver, and then I have my smart routing algorithm that figures out if you want to do a big trade, should you be trading on this curve pool or this balancer pool, or maybe should you be splitting over them. The problem is that none of these protocols are standardized. Everyone implements their curve math and their interfaces differently. And so as a solver, we and any other solver, we have to go and understand the internals of every single protocol. And this is the equivalent, more or less, of understanding what the developers understood when they developed these protocols. Why? Because every tiny bit matters when you simulate swaps over protocol, right? And many of these are completely customized on different pools. So there isn't one balancer. There are four or five different balancer pool types, and they're customizable, which means there's an infinite potential number of pool types. And for curve, similar. There's not one curve. There's 3 different versions, and then there's 12 different pool types. Integrating them is really, really a lot of effort. And it's not just indexing what I need to know to simulate, but also knowing how I simulate. What many solvers do is they go in and they replicate the entire curve math. And by curve math, I don't mean just curve, but the trading curves of all the protocols inside their own Rust re-implementation, so that they can efficiently simulate these protocols. Again, this only works if you understand every single little thing. And if you miss one hard-coded variable somewhere, you will error, your trade will not execute. And finally, solvers need to execute. And execution is really also not that straightforward, because you need to handle users' assets, and you need to handle them safely. And if you don't, you can really easily, during the execution, either lose your trader's assets or yourself be exploited if you approve against the wrong contracts in the wrong way. Also, you need to build an execution contract against every single pool type and against every single DEX that you want to integrate. And just a reminder, if you don't do this, you have no chance to have a business, because you are in direct competition with all other solvers and all other searchers who are competing over the same order flow. So if you miss a crucial protocol, you will not win that flow that needs that protocol. And if you miss a significant portion of all of the existing DEXs, then you will not win any flow in those competitive auctions. And this means that just to start, you are forced to go through all of this and spend a lot of time in order to catch up with the incumbents and get some flow. And only then do you actually earn cow rewards, do you earn on your trades, and then you can grow your team. But the longer the incumbents exist and the more DEXs there are, the harder it is for you to catch up. The harder it is for you to make your first buck, or you land your first searcher bundle, land your first one auction on CowSwap. And while I want to get a little bit more into the indexing problem, why specifically is indexing so messy? I think we've talked a lot about this today, so I'm going to go over this pretty quickly. Indexing by querying the nodes through JSON RPC calls is ridiculous. It is like having an API interface to an SQL database. Why not just talk to the database directly? Well, because we don't have that interface. And as I just said, all of these things, they add up to a massive barrier of entry for solvers, but also for searchers, also for market makers who want to trade on-chain, right? Don't forget that competitive market making on-chain depends on on-chain execution. You can't just access off-chain liquidity like on Binance. You also need to access on-chain liquidity to be a competitive SexDex arbitrager. And for that, you also need to have all these integrations. And for the whole ecosystem, it's a big pain because every single solver team re-implements this code. And I think a conservative estimate is we have 20 of those teams. I think we probably have more than 100 who have done this effort. And not a single one of them is incentivized to open source any of this because it is their competitive advantage. Now, is this a problem? I mean, it's a lot of added effort, and it's hard to get into this game. Maybe it should be that way. I think it is a problem because it leads to centralization. We see this today. Market makers are centralizing more and more. There are fewer and fewer players winning larger and larger parts of the flow. The same is true for searching. The same is starting to develop for solving. And we just recently, 2 months ago, we tried to help a new solver enter CowSwap. And it was extremely hard, and they gave up after a month and a half, seeing that the effort to become a competitive CowSwap solver on mainnet is simply too high. And this, I think, is going to start to happen from now on more and more, that we will not see new solver teams unless we change something. But again, maybe having an oligopoly is also not that bad. Why do we need decentralization here? Is decentralization absolute good, or can we live with this type of centralization? And I think we actually cannot, because ultimately the promise of DeFi is that not just the state and the chain is resistant against censorship and is decentralized and permissionless, but also that everything built on top of that chain, specifically the fundamental building blocks like swapping, are permissionless and you cannot easily censor them. And this is no longer the case if the actors in the trade supply chain centralize. Because the reality today is that you don't interact with DEXs anymore. You do not. You interact with solvers and with searchers and with market makers. And they are the middleman between you and the actual DEX. And no matter how decentralized the DEX, if the solver in between is centralized and they are told to censor you, then you will be censored. If the market maker in between is centralized and they decide to extract egregious fees from you, then you will be paying egregious fees. And this will then start to look uncannily a lot like TradFi, where you have incumbents that capture the market, that ossify around their technological advantage, and then increase the fees and extract, and are also very susceptible to censorship. Now, this is why I care, and also because on top of trading, we are hoping to build and move a lot of the world economy, and this will not fulfill its promise if we don't make sure that the trade supply chain stays decentralized and therefore censorship resistant and efficient, meaning low fees. Now, how can we possibly do this? And I think the simple answer is that we need to simplify the jobs of all of these actors in the trade supply chain. We need to make what they have to do easier so that more people can enter and more people can sustain a business, and they don't have to have a team of 20 people to be a participant in the trade supply chain. Now, today, we're introducing Tycho. Actually, we published this a week ago, but you're probably the first to hear about this publicly. And Tycho is a tool built on substreams on the graph to index, simulate, and execute, and make all of these parts easy. And I'm going to talk a little bit now how does Tycho do this. Also, before I go further, Tycho is entirely open source. Every part of Tycho you can inspect and run yourself, MIT licensed, and you can reuse it as you wish. And you can build on top of it whatever you like. Now, I mentioned these three parts, and I want to go over them now individually, like how do you solve this indexing problem? And I think the indexing one is the one we know the most about because we've heard about this a couple of times now, that it is ridiculous to ask a node for every single piece of data that you need through RPC requests. So Firehose and substreams make this extremely efficient by instead inverting the process and streaming the data to you. Now, Firehose has geographically distributed nodes that all race to provide the data. And then in substreams, we can define mapping modules and processing modules that process the block stream into exactly the pieces that we need for solvers. And then we stream them in real time to the solvers, so that you never need to query for the data that you need to search, to solve, to market make. You get it streamed constantly after every block. And this is extremely fast. I think we are averaging less than 100 milliseconds between the latest block and you getting the entirely processed data locally. You can also do this in parallel, right? If you do historical syncs and you want to build the state of, for example, Uniswap v3 with tens of thousands, maybe even over 100,000 pools, then you can go over the entire chain history, index all the pools that were generated, index all the ticks for them, and do this in parallel, which if you didn't have parallel processing, as far as you would wait for months to do this, and now you can do it in hours or days, index large protocols. And then we store this in a database, easily accessible, so solvers themselves don't need to run databases anymore. And then we can give snapshots of the historical state plus, as I said before, all of the real-time stream of the updates from the current blocks. Now, this makes it super easy for any solver to onboard, get all the state they need for the protocols and the dexes they want to swap over, and then continuously consume in low latency the updates that they need to solve. So this is the indexing problem. Now, we also have simulation and execution. Simulation is an extremely hard problem, as I said earlier, because all of these protocols expose different interfaces. This morning, we published ERC 7815. I mean, we got our number this morning. And this is an interface standard that we developed together with auctions like CowSwap and other solvers and searchers to capture exactly what a solver needs in order to simulate, like the price derivative, the amount out function, the swap to price function. These are things, I'm not going to go into detail, that you need if you're running, for example, convex optimizers over dexes in order to find the optimal route. By standardizing this, we're giving all of the dexes, not just the current ones, but also the future ones. Today, tomorrow, maybe, Uniswap v4 will go into production, and there will be many, many hook teams, each looking to get flow, each looking to get integrated in solvers. And they will have a very hard time to integrate into solvers if they don't comply with a standard that makes it easy for the solvers to integrate. This is something I didn't mention earlier on the centralization part. It's not just the participants in the trade supply chain, like the solvers and the searchers that are threatened to centralize. It is also the DEXs. If you are a DEX and you just launch, and no matter how good your design is, you have the chicken and egg problem of attracting liquidity into your pools and attracting solvers who integrate you so that you can get order flow in the first place. Almost no DEX today gets flow from their front end. They get the flow from all the routers, all the solvers, all the searchers that integrate them. And if they don't integrate you, you have no flow. And if you have no flow, you can attract no liquidity, which means that centralization and high effort to integrate centralizes also the DEXs, because as a new DEX, you have almost no way to bootstrap unless you have very large LPs who are willing to give you money before there's any flow to speak of. And solvers will not prioritize your integration if you don't have any liquidity. You can circumvent this if you implement a standard that you know that all solvers use and that you know that all solvers understand. For the solvers, it's a single integration into a single interface, one time. And the DEXs can proactively comply with the standard. And it also works, it's also backwards compatible. You can deploy an adapter and make this compatible with any DEX integration that exists today. And this allows the DEXs to innovate and more DEXs and more hooks to come on the market, because it's much easier to bootstrap flow. And this is absolutely impossible today, and one of the most urgent problems of DEXs. So standardizing the interface to DEXs fixes the simulation problem. And then we have the last piece, which is the execution problem. And last week, again, and it's not the first time, a solver got hacked because of a new adapter that they deployed to a new DEX, and their approvals got abused, and they lost, luckily not that much, but if it wouldn't have been noticed later, as early as it was, then the loss would have been much, much higher. I think they lost like 50K of the Cursor pool. And as I said earlier, building a router and building those adapters is a dicey endeavor, because if you make mistakes, you're risking the auction protocol and the user's funds. And what Tycho does is we have adapters and routers implemented together with the DEXs for every DEX, and each of those adapters and the router are audited by a third-party audit. This way, you can now use and execute over DEX liquidity as a solver without having to build, gas optimize, and check the security of your own router and adapters. And yeah, one thing that also maybe is underappreciated is that solvers, as I said earlier, are under high pressure to integrate new DEXs, because this is how they make money. Integrating a DEX earlier means you win flow that others can't win, so you're constantly incentivized to risk funds in order to integrate new protocols faster. Tycho completely eliminates this incentive by having DEXs integrate into Tycho before they even launch, meaning you have absolutely no advantage by jumping hoops. The adapters and DEX integrations are audited before they go live. This way, there is no more incentive to raise and risk user funds. Now, I said earlier, the goal is to simplify all of these 3 steps, and I just showed you how that works in Tycho. Now, what does that give us? If we have simple indexing, simple simulation, and simple execution, then we enable all of the upstream implementations to be much lower effort. So as I said, solving will become much lower effort. I think single-person teams can realistically do it. The same goes for searching, like backrunning, or writing your own liquid data if you're a DApp for your own protocol, writing your own OEV capture if you're an Oracle, building a price oracle on top of DEX liquidity also becomes much easier, because you no longer need to interface with all the DEXs. You can use a single interface. And then on top of that, that enables intent protocols to bootstrap themselves much more freely over many more chains today it is extremely hard to find solvers. And unless you are on mainnet and unless you already have a big brand, you have no solvers that participate in your auction. But if you make it extremely easy for solvers to build and for you to provide an open source example solver for your auction, then you have a much easier time to bootstrap a solver ecosystem for your auction. And the same goes for capturing MEV revenue as a sequencer, or even building trustless open source solvers that anybody can use and doesn't have to rely on the solver being a good actor. So having these things simple enables a whole set of open source and simple to implement use cases that then enable the intent ecosystem I think that many are building towards. Now, I already mentioned Tycho. If you go to propellerheads.xyz, you will see under products Tycho, and you can learn more about it. Where we are today is the Tycho indexer is live, and you can use it. Tycho simulation will go live in the next few days, and Tycho execution will probably come in a few weeks. I actually, if we are lucky, can do some demo. So, where's my mouse? OK. Nope, this doesn't work. Here. So here, this is So here we are running locally the Tycho client, and the Tycho client connects to the database that indexed all of the different DEX protocols. And what's happening in the background now is we're downloading a snapshot of all the state that you would need to simulate over any of these protocols, Uniswap v2, Uniswap v3, Balancer. And then it continuously listens to updates from every block. We're not going to see the updates of the blocks here because that's not what this interface is optimized for. But what you will see is a preview version of Tycho Simulate where you can simulate now over any of these DEXs. So these are the pool addresses. And if you go, for example, what are we going to do? Staked ETH. That's a simple one to understand. So this is, I think, a Uniswap v3 pool that we're going to see in a second. And we can now do real-time simulations over this pool. I'm just increasing the amount here. And you can see how long it takes. It's 8 microseconds to simulate over this pool. Now, you don't need to know anything about how the Uniswap v3, this is a Uniswap v2 pool, how it's implemented, how to simulate, how the curve math works. You simply just query amount in, and Tycho takes care of all of the calculation and the state management in the background. And this is based on real-time data from Ethereum mainnet. And you can do the same thing with thanks to Alan, he's here in the third row. He built this in a day 4 days ago. Now, if you want to run this yourself, what you just saw, you can go to GitHub PropellerHeads Tycho simulation, and there in the examples, you can run this same example and get exactly the same result in like 2 minutes. So if you take your laptop out, you can do this right now or anytime. And you can also then modify this for whatever purpose that you seek. Now, I invite you to start building on Tycho. If you are a DEX or anybody who has liquidity, stablecoin, vault liquidity, lending liquidity, anything that you want to get flow for, anything that you want solvers to use so that you have more usage on your liquidity, you can use Tycho. You can integrate today. Go to the docs page. I post in a second. If you have any sort of application where you want to route over DEX liquidity because you want to index, simulate, execute over because you are a solver, a searcher, a builder, a sequencer, because you are an auction, or because you want to build an intent protocol or Oracle, you can use Tycho today to index, simulate, and execute over on-chain liquidity. Yeah. And if you want to know anything more, reach out. This is my Telegram. You can just write me directly. Yeah, happy to answer any questions.
Thank you so much, Markus. Thank you very much. I think we have time for just one question. So I'll put the pressure on you, Markus, to pick somebody raising their hands.
Hi there, amazing talk. Thanks for outsourcing and publicizing the solvers. I'm actually with Curve Finance, and thanks for memes. My question is, what are the major pain points and how can we make your life better from the DEX side?
Can you pass the mic to Alan?
So basically having like one interface to swap or like to compute basically marginal prices. And if you look at the adapter interface that is public on GitHub now, basically exposing this or implementing this for your protocol, it makes the life for all servers much, much easier.
All right, thank you for that question. Thank you so much, Markus. Really appreciate you joining us today.